All right, so this is lesson 9.1 to do with pre-calculus part before we get into the calculus part. It says when using a calculator with trig functions, it's important that the calculator is set in the correct mode, radians or degrees. We just talked about that. Make sure that, again, if you look at your calculator, if you press the home button, that's the on button, and go to settings, which is number 5, and then go to document settings, which is number 2, do you see as you go down there, there's something that says, the second one there says angle. If you go down, if you highlight over that one, somewhere there it is, and press the right across, you have a choice between radian, degree, and you don't care. So, pick radian or degree. 99% of the time you want it in radians. So, in case something happens in life, you go, man, I don't know, it doesn't say RAD in the top right. Do you know how to change it to radians if you have to? All right, press the escape button, or press OK down here, I guess. Press the scratch pad. You can press it once for the graph or another time just to be able to calculate something. In example number 1, it says use your calculator to find these things. And if it doesn't tell you otherwise, we're going to assume it's all in radians. So even though it's an awkward looking thing, do you know where sine is on your calculator? Oh, that would be a good place to start, right? You know what's beautiful about this calculator? Honestly, the interface is that when you press trig, all 12 are there that you would need, right? That would be all 6 and its inverses, right? That's nice and quick, right, to get to what you need to. So I'm going to go to sine. I'm going to put 2 in. And then what should I round it to? So what would that be? 0.909. Keep going. Tangent, where am I going to go again? The trig button. And now this time go to tangent. Remember the little negative ones are inversed, right, of whatever is above it. We'll talk about that later on in the unit. Put in your fraction. This one is negative pi. Where do I find pi again?
Down there.
Down there, thank you. So like on the bottom left there?
Yes.
And notice that's not just for pi, but a bunch of other fun things like infinity, degree sign, I, whatever that is in math, right? So right now it don't matter. Pi. And then in the denominator, 5. And it's negative 0.726. Remember, you can truncate, right? You know what that means? Just the first 3 numbers you see after the decimal, just write them down. That's truncating. And the last one, secant. Do you know where? Again, press the trig button. Go to secant. Press enter. Put in 1.3. Easy, right? Make sure control enter, right, gives you the decimal. Did you know that? Of course you did. Control enter, and it's 3.738. All right, now example number 2. It says use a calculator to find the missing measure in each triangle. So the missing measure here is what? The hypotenuse, which is x, the missing side. What are you given in this triangle? You're given a side length, which is 5. This is an awkward way to write an angle, but that's 0.5 radians, so you're given an angle. And so how do you find a missing side in a right triangle using trigonometry? That's right, like a sushi restaurant. Soka-toa. In this case, which one of those will I use based on what I'm given, right? So do you see the angle? What's given is the opposite, and what I'm looking for is the hypotenuse. Whenever you use SOHCAHTOA, right triangle trigonometry, you have to start with an angle. Either it's an unknown angle or you know the angle, but opposite has no meaning unless you go to the angle first and then it's opposite. All right, so it is sine. So it's the sine of 0.5. It's in radians. It's fine. You don't need a little r there. 0.5 is good. And then what fractions on the other side? The opposite side is 5, and then the denominator is x. Do you want to solve it? Let's do it. What would you do first?
Multiply times 5.
Nope. I like that. I'm hearing Candelario. He says to multiply both sides by x. That's beautiful. And then what would be the next step to get x by itself? Divide by sine 0.5, then use your calculator. When you're bored, you should see if you can type that in and use the solve equation button on your calculator and not even do the algebra ahead of time. Maybe if you typed in this trig equation and said solve for x, you should see what it gives you. Go for it. So I'm going to type in 5 divided by sine 0.5. Oh. And what would you write the answer as? 10.429. Did you get the same answer using the solve button? So just a reminder, it might be a very helpful button, right? That when you go to menu and you go to algebra, even though it's trigonometry, go to algebra and then click on solve, you could type in the equation comma x, right? Especially if it's more complicated. That would be helpful. And you're allowed to use a calculator. Why not? All right. B. How would I solve for theta?
Tangent.
So when I look at the unknown angle, what's given is the opposite. What's given is the adjacent. Don't know the hypotenuse. So opposite over adjacent. Yes, that is tangent. So it's 2 over 5. Be careful here. If you try to use your calculator and solve an equation that's an angle, much different. There's an infinite number of angles that could give you the answer 2 over 5. So it won't give you the acute angle you're looking for. So it's more challenging. I'll show you what you're going to do in a second. But it's more challenging just right there to use your calculator from this point. When you're solving for a missing side, there's no challenge. The angle that's unknown, there could be multiple angles that could give you that answer. Okay? So, yeah, go ahead. Yeah. So to get tangent by itself, you have to do the inverse. So to get theta by itself, it's the inverse of 2 over 5. Your calculator, when you type that in, will only give you one answer. By definition, the inverse, when it's positive, it will only give you the angle in quadrant number 1, the acute angle you're looking for. So, again, trig, inverse, tangent, 2/5. And what angle did you get? Now, recognize the angle is in radians. That's why it looks awkward. 0.380. Here's a challenge. You ready? Find the angle in degrees, even if the question asks for it. What would you do? 0.380 is in radians. If you wanted that angle in degrees, could you? Go for it. So I'm taking the answer times 180 over pi. So in degrees, it's approximately 41 point. I know. I'm saying our answer's in radians. I said for fun, if you had to, could you quickly convert that to degrees? Because when you say, oh, the angle's 0.38 radians, it doesn't feel right in the tummy. But 41.81 degrees, whatever, that feels like, okay, I get it now. Yeah.
What was the answer on the calculator?
For which one?
21.
Did I write down the wrong one? 21. Whatever the calculator said. 21.810. Or 801. All right. Next, graphing. Trig functions are periodic. What does that mean? They keep repeating over and over and over again forever, right? The sine, cosine, cosecant, and secant functions all have a period of 2 pi. That means over 2 pi, whatever you do from 0 to 2 pi, that part repeats over and over and over again. Tangent and cotangent have a period of pi, so from 0 to pi, that part repeats over and over and over again. You should be able to easily graph trig functions using trig values of 0, pi over 2 pi, and 3 pi over 2, and 2 pi. Why? Because those are points on the axes. They are not irrational, but they are rational. Can you graph y equals sine x? Did you already finish the front page? So as I look at you and want to tell you, good, you should invest in a bookmark. Then you know exactly where you are. All right. So this is partly understanding the unit circle or understanding the graph. They go together. Where do you think I should start on the y-axis for y equals sine x? So it does start at 0, 0. You need to know that sine would start in the middle of the wave. What happens at pi over 2? Goes up to 1. At pi, it goes back to 0. These are the y coordinates, right, along your unit circle. 3 pi over 2, it goes down to -1. And then 2 pi goes back to 0. On the left, you can follow the pattern now, going to the left. So if you follow the pattern, where should negative pi over 2 go? Following the wave. You only should have 2 options here. Which one's the right option? -1. Then 0. Then +1. Back. And it goes forever, so we need arrows at the ends. What does cosine x look like? It does start at +1. 0, +1. It's the x coordinates going around the circle. What's the x coordinate on the next axis? 0. What's the x coordinate on the next one? Can you see the wave? What's the pattern once you finish the 0 to 2 pi, going clockwise, counterclockwise, going the other direction, negative angles? What's the pattern? Here's a great question. Which one's the odd function? Which one's the even function? A great question. Of sine or cosine, which one's odd and which one's even? By looking off the graph. Sine is even. Why? So I'm going to remind you, I like your confidence, that even means it reflects over the y-axis, right? That if you fold it over the y, one would be on top of the other. Is that true for sine? No. In fact, which one is an even function? Right? That means if I put in positive pi or I put in negative pi, the answer is the same. If I put in pi over 2 or negative pi over 2, the answer is the same. That's part of that definition. So which one's even again? Cosine. Well, which one's odd? So that means if I look at pi over 2, the answer is +1. And if I go to negative pi over 2, the answer then would be negative. That's that connection. Or you can see there's symmetry with the origin. That means the top right and the top left have symmetry. Kind of the quadrants there, if you like. Anyways, which one's odd? Sine? Or not. Which one's odd? Sine. Which one's even? Cosine. All right. C. Kisk. X. Kisk. That was too far along, right? So a good place to start for cosecant is to understand the unit circle and understand, okay, if I just do the axes points, that's 1, 0, that's 0, 1, that's negative 1, 0, and 0, negative 1. Just the axes points. The definition of cosecant is the reciprocal of y coordinate, right? What's the y coordinate to begin with at 0? 0. And you know what? Before you tell me the wrong answer, the reciprocal of 0 is undefined. So 0 over 1, right, is 0, correct? What's the reciprocal of 0 over 1? That's right. And that means it's undefined. And so when something's undefined, what do you do on a graph? That's right. No. Well, it could be a hole, but not. Asymptote. Hole is only a point. When there's an infinite number of points along there, it's an asymptote. Yeah, we got it. Now, what happens at pi over 2? What's the y coordinate? 1. What's the reciprocal of 1? 1. 1 over 1. What's the reciprocal of 1 over 1? Next, pi. What's the y coordinate at pi? 0. What's the reciprocal of 0? Undefined. So what happens at pi? Okay, at 3 pi over 2, what's the y coordinate? Negative 1. What's negative 1 over 1? What's the reciprocal? Which is? Done. There's got to be a pattern you see now. What's going to happen at negative pi over 2? No. Yes. And at negative pi? At negative 3 pi over 2? And at negative 2 pi. If I did not have asymptotes and I connected these points as a wave, it would look like sine. But it's not. But these points share with sine. And whenever sine's in the middle of the wave, those are undefined. That's where the asymptotes go. What does the picture of cosecant look like between the asymptotes? Good. And the upper vertex folds up, and the lower vertex folds down. Sorry, at 2 pi there's also a asymptote. All right, now that we have, so is this a waste of energy to just draw a unit circle and put down the axes points? Okay, secant. What happens at 0 degrees or 0 radians?
1.
Good, because the reciprocal of 1 is 1. What happens at pi over 2? Yeah, because the x coordinate is 0. What's going to happen at pi? Negative 1. Are you seeing a pattern? Is there a folder in your brain that opened up, like a tulip in the morning? Whatever, right? You know a tulip flower, did you know they close at night and then they open in the morning? You've now learned something. There are flowers that close at night and open in the morning. Did you know that? And a tulip is one of them. Now you can go home. What did you learn at school today? You now got it. A tulip closes at night and opens in the morning, just like your mind. Closes at night, they can open again in the morning when you come to school. Does it stay open the whole time? It's closed the whole time? All right. Again, hey, if I connected these points as a wave, it would make cosine. But it's not. So, what picture again is it? And the lower vertices fold down and the upper ones fold up. All right, turn the page. Oh, you thought we were done, but no, there's 2 more graphs. No! It does. So guess what? Remember the unit circle we drew? Do you know it in your head or do you need to write it down? Just the axes points. Recognize that tangent is y over x. That means that when you look at those points right around the circle, so the first point again is 1, 0, 0, 1, negative 1, 0, 0, negative 1, y over x, 0 over 1. What's the answer? Please don't say the wrong answer. 0 over 1 is what? 0. Then when I go to pi over 2, what's happening? What is 1 over 0? So when the 0 is being in the denominator, right? So at pi over 2 is the asymptote. What's happening at pi? 0 over negative 1, which is 0. Follow the pattern over here. At negative pi over 2, it's undefined. And then at negative pi again, it's 0. All right, we're going to graph these. Do you know what the picture looks like between the asymptotes? Not parabolic. That's right. It's going to look like a cube function, right? So one half folds up and the other half folds down. There's a point of inflection. So a point of inflection means, again, where the concavity changes, right? Yay. So let's start right here at 0. I need you to recognize that between 0 and pi over 2 is quadrant number 1. And tangent in quadrant number 1 is positive. It's going up to the right, concave up. And what happens to the left? Concave down. That point of inflection. And that pattern of that cube-looking function, right? Up one way, down the other way, continues. So here it's going to go down. If we continued it, which it doesn't, it would go up to the right. So this side goes up to the right, would go down to the left. Cotangent. What's going to happen at 0? Well, what's the definition of cotangent? Right, so it's x over y. So when I look at 1, 0, it's really x over y. 1 over 0, which is undefined. So at 0, what is it going to be? Yep, and at pi over 2? Yep. And then again, it's going to be an asymptote. Follow the pattern on the left. Now, what direction does this curve to have an understanding? So, recognize that between 0 and pi over 2 is quadrant number 1. Cotangent in quadrant number 1, like all trig ratios, they're all positive in quadrant number 1. So between 0 and pi over 2, what direction is it going to fold? Up. In between pi over 2 and pi, it's going to fold down. It's going to fold up. It's going to fold down. So in layman's terms, the tangent goes up to the right and down to the left, and the cotangent the other way, up to the left and down to the right. Those are the 6 basic trig functions that you need to know and memorize. So the unit circle and 6 trig functions can you graph? The unit circle and these 6. So now let's look down. I'm going to kind of ignore the box here. If that's helpful to you to be able to know how to analyze it, awesome. If not, then listen to me. It says, can you graph 2 cycles of that function? Negative 5 cosine x over 2. So I'm going to tell you directly that you should start with the parent graph and write down the parent points and transform them. What is the parent if it was just cosine x? The one we just did on the last page. And we're just looking at the axes, right? So at 0 degrees, what's the answer? Or 0 radians, right? At pi over 2, what's the x-coordinate at pi over 2? 0. I'm going to continue down here. At pi, what's the x-coordinate? Negative 1. At 3 pi over 2? 0. And that's it. Then 2 pi is really the same as just 0, right? So we don't need it. 4 works, right? Now, when I look here, whatever is outside the function only affects the y-coordinate. Whatever's on the inside affects the x-coordinate. So what do you see on the inside? Divided by 2. What's the inverse of that? That affects the x-coordinate. So instead of dividing by 2, we're going to... So every x-coordinate, what are we going to do? times 2. So 0 times 2?
0.
Pi over 2 times 2. Pi. Pi times 2? 2 pi. And then 3 pi over 2 times 2. The 2's divide out, and you just have 3 pi. Do you see a pattern? 0 pi, 2 pi, 3 pi. The next one would be obviously 4 pi, and so on, right? There's a pattern to all of these. What number do you see on the outside of the trig function? And it could be both there and behind. -5. What is it doing? Multiplying. And it does what it says. So every y-coordinate, what are you going to do? Times -5. So 1 times -5, 0 times -5. Negative times a negative, and then 0 again, right? Now we have a pattern. Those 4 give us a pattern. We can go forever and whatever direction we want to go to. So 0, -5, and then pi 0, two pi 5, and 3 pi 0. So where would you consider this pattern? Where would 4 pi be? The bottom. And then follow the pattern on the other side. Recognize it goes forever. There's no endpoints. But it doesn't go forever down, right? You have to show the direction it's going. So notice that I point that the arrows are pointing up at the end. They're not pointing down this way, right? It's not going lower than that. That's the minimum, right? It's going to go back up from there. All right, B. What are the parent points for sine? I'll do that underneath here.
0, 0.
0, 0. So in other words, I'm thinking at 0 radians, what's the y-coordinate? 0. At pi over 2, what is the y-coordinate? At pi, what's the y-coordinate? 0. At 3 pi over 2, what's the y-coordinate? Do you see how they're connected? The unit circle and graphing, right? If there's pre-calculus, you got to take with you, right? That's it. Now, do you see anything inside the parentheses? You have to do the inverse of what you see. I'm not, 2 pi is the same as 0, so I just need those 4, and then I can follow the pattern from there. What would be the inverse of what you see inside there? Do you know? Take what you see inside the parentheses. Make it equal to what is the x-coordinate you're changing. The inverse is your ability to get t by itself. What are the 2 steps to get t by itself? Add pi over 2, and then what? Divide by 2, which becomes pi over 4. Notice the y-coordinate does not change. Why doesn't it change? Nothing on the outside, right? So what are the 2 things I'm going to do to every x-coordinate? Add pi over 2 and then divide by 2. Let's go. We can do this. What's pi over 2 plus pi over 2? What's 1/2 plus 1/2? 1 pi. And then take that answer divided by 2. The y-coordinate stays the same. There's going to be a pattern here. Pi. What's pi plus pi over 2? What's 1 and another half? 1.5. 3 over 2, right? 3 pi over 2 divided by 2 is 3 pi over 4. Are you seeing a pattern here? Think money. What are you going up by? Quarters. What do you think the next one is going to be?
Pi.
Yeah. And the y-coordinate stays the same. See the pattern, follow the pattern. Now let's plot the points. So pi over 4. Notice the scale, how it's done. So the first tick mark is pi over 4 and 0. Pi over 2 and 1. 3 pi over 4 and 0. Pi and -1. And then follow that pattern. Notice here, what direction is it going to be? 2 right beside each other that are maximums? It has to oscillate, right? Top, middle, down. Top, middle, down. Top, middle, down. It's got to oscillate. If 2 peaks are beside each other, then you didn't follow the pattern. Now, I ain't done. Now, in example 4A, if I asked you what's the amplitude, what would you tell me? The answer would be positive 5. Amplitude's always written as a positive number. If I said that for B, what's the amplitude? You'd say 1. If I said, what's the period? How long does it take to complete a cycle? For A. And the answer is 4 pi. Right? It doubled, right? And how long it takes. If I ask the same question B, how long it takes? It would be half, right? To pi. Good. Now turn the page. Oh, the rest I will continue.